Hello everyone, welcome to our second lesson of our online math class. Today we're going to continue our lesson with exponents. And our objectives for today is, at the end of this lesson, you are expected to review the parts of an exponential expression. Number 2, express the rules of multiplying and dividing exponents or exponential expressions. Number 3, you're going to evaluate or simplify exponential expressions. So these are the 3 things that we're going to do today. And we have our very first vocabulary, which are very helpful because I'm going to say it again and again in this online class. Okay, the first one is add, subtract, multiply, divide, and expand. Again, the vocabs that we will use today are add, subtract, multiply, divide, and expand. Okay, now the first thing that we have to do based on our objective or objectives, we need to review how to change this expression into exponential form. And we're going to indicate or tell what are the base or what is its base or its exponent. So the first example here, okay, is we have 2 times 2 times 2 times 2. So we learned already that if we have the same base, we write the same base and the number it repeats. So it repeats 4 times, so it will be 2 to the power of 4. Now, we remember that we write the exponent first. Okay, we write the exponent first, which is 4, before writing the base, so that we will know what is its base. Sometimes, because like for example in number 3, negative is not part of the base. So yeah, we need to identify the exponent first. So number 2, we have 64. 64, I'll change it to 2 times 2 times 2 times 2 times 2. Okay, so 64 is 8 times 8. And 8 is 2 times 2 times 2. Same thing with the other one. And we have 2 to the power of 6. 1, 2, 3, 4, 5, 6. Exponent is 6, base is 2. Alright, so let's move on to number 3. Now, 81 is 9 times 9. 9 times 9 is 3 times 3. And another 9 is 3 times 3. Okay? Now, 1, 2, 3, 4. 3 to the power of 4. Now, like what I said a while ago, we write the exponents first so that we will identify its base only. Okay, in this case we have 3 only. Now let's move on to question number 4. Okay, number 4, we have 3m squared times 3m squared. They have the same base, so we have 3m squared squared. Okay, now exponent is 2 because it repeats 2 times. The base is 3m squared. Alright, let's move on to number 5. Okay, number 5, we have 3 squared, 3 times 3, and 3 to the power of 5. 1, 2, 3, 4, 5. Okay, so 3 squared, 1, 2, 3 to the power of 5. 1, 2, 3, 4, 5. How many 3's are there? 1, 2, 3, 4, 5, 6, 7. 3 to the power of 7. Okay, exponent is 7. The base is 3. Okay, very simple. And that's the end of our review. Alright, let's move on to our first concept for this lesson. Now, maybe some of you learned this already, that when we multiply exponential expression with the same base, you add the exponents. But here's my question. Why? Why do we need to add the exponents? if they have the same base, right? Now let's look at some common answers. All right, so I've been teaching for more than 10 years, and these are the answers that I receive from most of my students. Okay, this is the number one. Okay, the it's math rule. Hello. Okay, so yeah, I know, but why? All right, so and and this is the second one. All right, so IDK and IDC. I will follow my teacher. Teacher David says do this, you have to do this. All right, so yeah, IDK means I don't know, and IDC is I don't care. All right, so they just follow the teacher, which is bad because learning should have a reason. Okay, that's what we need to develop in our class, especially with mathematics. All right, so 3 to the power of 3 to the power of 3, or 3 cubed, times 3 to the power of 4 is equal to 3 to the power of 7. All right, now we're going to investigate it. All right, okay, now since we are the last FEP of Matayom, all right, I made this up. All right, so it's nice. Okay, so first one, and we will follow this. All right, FEP, fix if possible. All right, you have to fix if possible. 2, expand if needed. You have to make it longer, right? And letter P is process, means to say you have to do the rule, or you have to combine if you need to combine. All right, so all right, so here's our problem. 3 to the power of 3 times 3 to the power of 4 is equal to 3 to the power of 7. Okay, now we need to fix it, but it's already fixed. So what we will do, we will expand this. All right, so 3 to the power of 3, 1, 2, 3, and 3 to the power of 4, 1, 2, 3, 4. I'm counting the number of the threes here. All right. Okay, so this is 3 to the power of 3, 1, 2, 3, and 3 to the power of 4, 1, 2, 3, 4. Now we will do the process. Okay, so we will do the process. So there are 7, right? Okay, so we have 3 plus 4 equals 7. Beautiful, right? So that is the reason why we add the exponents when we have the same base. All right, now don't forget, fix if possible, expand if needed, and last one is process. Okay, let's look at example number 2. You have negative 2 to the power of 2, negative 2 to the power of 3, and negative 2. But remember, every number has an exponent of 1, so we have to fix it first. Okay, so you will not be lost. All right, so you see this one should have a 1. That's why the fixed part here. Okay, 2, 3, 1. Now if you need to expand it, yes, you can expand it. Negative 2 to the power of 2, 1, 2. Negative 2 to the power of 3, 1, 2, 3. Negative 2 to the power of 1, 1. Okay, you see there are colors here. Okay, so negative 2 is repeated twice. Negative 2 is repeated 3 times. 1, 2, 3. And negative 2 is repeated or just written 1. Okay, now if you count all the negative 2 together, we have 1, 2, 3, 4, 5, 6. All right, so it's the same thing of our based on what we learned. So the exponent is the it tells us how many times the base repeats. All right, so we have negative 2, negative 2, negative 2, and repeat. Okay, so 1, 2, 3, 4, 5, 6. Now we use the okay, so it's a hassle if you write the negative 2 the expand part, but you see this is quite simple. All right, you just add the exponents. All right. Okay, so 2 plus 3 plus 1 is equal to 6. Or 2 to the power of 6. Okay, why? Why is it 2 to the power of 6? Since this is an even exponent. Okay, so you can write this as a positive number. Okay, so you can check further. Negative 2, negative 2, negative 2, negative 2, negative 2, and negative 2. Alright, so negative and negative, positive. Negative and negative, positive. Negative times negative, positive. They're all positive. Okay, that's why our answer can be 2 to the power of 6. Now let's look at the next example here. Alright, so the first thing we have to do, okay, is we need to fix this problem. Right? You have 2 to the power of 2 times negative 2 to the power of 4. Okay? So you have 2 times 2, okay? And negative 2 times negative 2 times negative 2 times negative 2. Now, here's the problem. These base are the same. These base are the same. These ones are not. Now, let's simplify it. Simplify their sign. Okay, so negative times negative, positive. Negative times negative, positive. Right? So now, do we have the same base? Yes, we have the same base. Alright? So we have 2 times 2 times 2 times 2 times 2 times 2. That's it. Okay? So we process it. This will become 2 to the power of 6. Okay, very simple. Now, let's look at question number 4, example number 4. A to the power of m plus n times a to the power of m minus n. Now, it's a bit confusing because we have a group here. Alright? So, some of you can run right away to the process, but make sure that you know to add the variables correctly. Okay? So, for fixing this, okay, we will do the opposite way. So remember, a to the power of m times a to the power of n is equal to a to the power of m plus n, right? So we multiply the same base, we add their exponents. Now we will fix it. We will do the opposite way, a to the power of m times a to the power of n. Right, so that's the first one. Second one, a to the power of m, all right, times a to the power of negative n. Now we changed m minus n, all right, so we changed this one. Okay, we change a to the power of m plus negative n. So we change the sign into a plus sign. Now it's fixed. Now we don't need to do the expand part. Okay, so what we will do, we will combine this together. Okay, am times am times a n times a negative n. Now we add this m together. Alright, times a to the n minus n. Oh, alright, we have a to the power of 2m times a to the power of 0. Okay, so since we didn't learn a to the power of 0 still, okay, we will not simplify it right away. So since they have the same base, 2m plus 0 is equal to 2m. Alright, now maybe you think that Teacher David, a to the power of 0 is 1, but we will learn that one on our next lesson. But for today, we just need to combine the bases, all right? And we follow the rule that if they have the same base, we add them. So 2m plus 0 here is equal to 2m. Okay? All right, so concept number 2. Okay, so if concept number 1, if we add the exponents when we multiply the exponential expressions with the same base, why do you think we subtract? Okay, why do we subtract the exponential expression if they have same base, or when we divide the exponential expression with the same base? Why do we need to subtract them? Okay, all right, so let's look at our investigation here. N to the power of 5 divided by n to the power of 2. Now we will fix it into a fractional form. We have 9 to the power of 5 divided by 9 to the power of 2. Next is we expand it. All right, so we expand it. We have n times n times n times n times n divided by n times n times n, which is n squared. What we will do, all right, we will process it, and we're going to cancel the 9. All right, so 9 here, we'll combine them. It's equal to 1. And cancel it. Right, so we have 9 times 9 times 9. So we have 9 to the power of 3, which is the same as 9 to the power of 5 minus 2 is equal to 9 to the power of 3. Okay, this rule works well, okay, because we cancel the same variables or numbers together. Okay, so let's look on x to the power of 8 divided by x to the power of 5. Okay, so we don't need to fix it. Okay, so we just have to expand it, okay, and then cancel it right away. 5, 6, 7, 8 divided by 1, 2, 3, 4, 5. Okay, so we cancel all the x together. 1, and then change the color. 2, 3, 4, and 5. Okay, so the process here, we have x to the power of 3, or based on our rule, 8 minus 5 is equal to x to the power of 3. All right, very easy, very simple. Now we will look at this example number 3. So you have negative 24 m to the power of 5 divided by 6 m squared. Now the first thing we have to do, because this one are not the same base, what we will do is we just change it into a fractional form. All right, like this one. All right. Now if you want to expand it, you can expand it this way. Negative 24 m times m times m m times m equals r over 6 m times m. So we cancel 24 and 6, we get 4. Cancel all the m, 1, 2. Okay, so we process it out. We will have negative 4 m to the power of 3. All right, very nice. So let's have example number 4. Okay, quite simple. You have 2b to the power of 7 divided by 2b to the power of 6. They have the same base. All right, so we don't need to fix it. We don't need to expand it. We can just write the last process. So we have 2b to the power of 7 minus 6 is equal to 2b to the power of 1, or just write 2b. Okay, very nice, very easy. Okay, so for example number 5, okay, so yeah, we no need to fix this. Expand, it's not a problem. Okay, we can just write the process here. 7 minus 5 equals 2. Alright. Alright, so for last part, I want you to make a video. Well, you are at home, so it's homework also. Make a video of yourself about the multiplication rule and division rule. Give 2 examples. Okay, you can think of any 2 examples that you can divide or multiply, and then use your phone. Okay, take a video of yourself. Okay, explain it or with a paper, or if you have some writing, you can write it down. Okay, up to you. Okay, just just make a video. Okay, so that I know that you understand well why we need to add when we multiply exponential expressions when they have the same base, or subtract if we divide exponential expression with the same base. Okay, once you're done with your video, send it to your to our Google Classroom. Okay, I'm going to check your work. Okay, and make sure you enjoy your making video. Okay, so I hope you stay safe and stay healthy. See you guys next class.